right, we're looking at, excuse me, we're looking at P7, where our goal is to simplify square roots. Just to make sure everybody's on the same page, square root, so a square root, it is the opposite, so it's the opposite of the exponent. More specifically, an exponent with the second power. Now, a quick example. So if we were to take 7 times 7, right, we know 7 squared, 7 raised to the second power, is 7 times 7, and that we know to be 49. Right, so if we consider this to be forwards, then we could take a look at the square root of 49, and we know that the square root of 49 then would be 7. Right, so if 7 to the second power, if that's the forward, then backwards would be a square root. So if I'm looking at something like the square root of 81, I'm asking myself, when I see this symbol here, I'm asking myself, what number times itself is 81? And we all know, okay, the square root of 81 is 9, right? And the other ones, like the square root of 25, that's going to be 5. Or the square root of, I don't know, like 16, it's 4, right? So this square root symbol, it really means what number times itself gives me this, whatever is on the inside. Oh, I guess there's too much ink on the pen. Okay, well, that's nice and all. Like if I had the square root of 25 every time, I know it'd be 5. That's great. But so now the question is, what happens? So what happens when the numbers aren't pretty? All right, so the square root of 25 we know is 5. The square root of 81 is 9. The square root of 9 is 3, right? So we know all the little ones. We should be good with those. But what happens if I have something like, here, let's take a look at this example, the square root of 75. Well, the square root of 75, well, that's not really pretty. So there's no number times itself that's going to give me 75. So I need to do some things here. The first thing I'm going to do is I'm going to find all the prime factors. So I want to find the prime factors. And this is going to end up being a tree. So I take 75 and I break it down. What two numbers multiply to get to 75? Well, I know that 75 ends in a 5, so I know that it's at least divisible by 5. So if I get my calculator out, I say 75 divided by 5, and I get 15. Well, I know 15 is a product of 5 and 3. And had I started off with like a 3 and 25, I would have ended up with all the same ones. So my prime factors, I can't break 5 down any further. 1 and 5, well, I don't want to break it to 1. 1 is kind of a redundant number whenever it comes to prime factors. So the second thing I want to do, and my second step, is to circle. I want to circle groups of 2. So what I mean by that is 5 has another friend in 5, right? So I'm going to circle this group of 5s, and then I'm going to box the singles. And so I put a box around all the single ones. So 3 does not have another friend. Mind you, I want you to be really specific. We're only looking at the ends, the prime numbers at the end of the branches of this prime factorization tree. All right, so the 5s I'm going to circle. The 3, he doesn't have, there's not another 3 around here. So I'm only going to circle the 5s and I put a box around the 3. Now, step 3. I need to know what comes out and what stays under. Okay? So, what comes out? The things that I have circled, I get 1 to come out. So the things that I circle, I get 1 to come out front. So here, there's 2 5s right now, but I'm only going to drag 1 5 out front. And I'm going to leave what stays underneath. Well, everything in the box is going to stay underneath the radical. And then step 4, and we're going to see this a little bit later, not on this particular problem, but on step 4, I need to simplify if it's necessary. So simplify if, I would say if needed, only because I don't know how to spell the word necessary. You mean to tell me that I got a degree and I don't even know how to spell the word necessary? Yeah, that's true. That's kind of an embarrassing thing, but I'm all right with it. All right, so let's do a couple more examples. Let's take a look at the square root of 216. All right. So when it comes to finding prime factorizations, one thing I'm really looking at is, the things that I'm really looking at, can I divide by 2? Divide by 3? Or divide by 5? In general, I want to look for him first. Then I'll look at division by 2s, and then I'll look at division by 3s, the third. And really this helps me because after you get through the 2, 3s, and 5s, the 7s will start to jump out, and other numbers might jump out as well. 11s, for example, might as well jump out. But I try and start with 5, and I ask myself, the last digit, is that a 5 or a 0? In this instance, no. So I can't divide 216 divided by 5. Then I ask myself, is it even? If it's an even number, I can at least divide it by 2, right? So 216, I know, is divisible by 2. And half of 200 is 100. Half of 16 is 8. So I end up with 108. Now I look at this again and I'm asking myself, is this divisible by 5? No. Now I go 108. Is that divisible by 2? Well, sure it is. 2 and 54. Now you might see at 54, well, that's a product of 9 and 6. Great. If you see that, awesome. If not, you could still keep going by 2. And here I get 2 and 27. And now I'm going to see, oh, okay, well, this is 3 and 9. And here's 3 and 3. And so some of these numbers, you're going to have a pretty big area to do this, and that's fine. Remember, so now that's step 1. I have all my prime factorizations. I can't break down 2s and 3s anymore. So now I'm going to circle groups of 2. So this 2 has a friend right here. That 2, there's not another friend to go with that 2, so I'm going to put a box around him. You have a group of 3s. And there's not another friend for that 3, so I'm going to put a box around him. So the next step, I look at the circle groups, and those are going to come out front. So the 2 is going to come out front. A 3 is going to come out front, and I need you to know this is multiplication. And now what's going to stay underneath? We have a 2 and a 3. And now I'm going to simplify. Well, 2 times 3 is 6, and 2 times 3 is 6. And that is as far as I can take it. So the square root of 216 really breaks down into 6 roots of 6. All right, let's try another one here. Let's try something. Yeah, let's try a really nasty one. Let's do one with like big old numbers and stuff. Actually, we'll do 2 more. First one here. Let's try this. What about 5 square roots of 45? Well, I already have a number out front. So I'm going to leave him alone, and I'm going to underline him to remind myself, I'm going to visit you later. Now I need to break down the 45. Well, 45 is divisible by 5 because it has a 5 and a 0, and 45 divided by 5 is 9. And then 9 breaks into 3 and 3. Then I circle my groups of 2, and I put a box around the other ones. Now, it looks like I could have circled these guys, but this 5 is not on the end of the branches of the tree. He's already out front. So since he's already out front, I'm going to leave him out front. And then I'm going to take my 3 out front, and then the 5 stays underneath. 5 times 3 is 15, and I have the square root of 5 left underneath. So 5 times the square root of 45 is the same thing as 15 times the square root of 5. All right, let's do one more example, and this time let's go with some pretty gross numbers. And again, I want to show you that it's really not nearly as bad as what it looks like. So 11 times the square root of 1,215. At first glance, this looks terrible. But again, I want you to remember, all I'm going to really do is deal with 5s, 2s, and 3s, okay? So 5s, 2s, and 3s. Even though it's a giant number, it should work. So 1,215 is clearly divisible by 5. And when I plug it in my calculator, I end up with 243. So then I ask myself, is 243, is that divisible by 5? No. Is it an even number? No. And then if I just add these up, 2 plus 4 plus 3, so 2 plus 4 is 6, 6 plus 3 is 9. Since 9 is divisible by 3, then 243 as well is going to be divisible by 3. That's one of the sweet tricks of factoring. If you can add up all the digits and they're divisible by 3, then the number itself is divisible by 3. Super cool thing. Alright, so I know it's divisible by 3, and then I plug it in my calculator, and I can see, and I get 81. Well, good. I know that 81 is 9 and 9. And then I get 3 and 3 out of the 9, and 3 and 3 out of that 9. Now I'm going to circle my groups of 2. Well, these guys are already together down here, so I'm going to let them go ahead and be friends. Well, that 3 doesn't have another friend to go with it, and that 5 does not have another friend to go with it. Alright, so now, what comes out front and what stays underneath? Well, the 11's already out front, so I'm going to have him out front. Then we have that 3. And then we have that 3. And now what's going to go underneath? Well, I have the 5 here and that 3. Alright? And now I can plug it in my calculator. 11 times 3 times 3. You can see that. Or 3 times 3 is 9. And 9 times 11 is 99. 5 times 3 is 15.